A swimmer swims directly across a river. She swims at 2 meters per second relative to still water. She swims to a point 50 meters downstream from her starting point. The river is 120 meters wide. Find the following: A, the speed of the current, B, the swimmer's final speed, C, the time it takes the swimmer to cross the river, and D, the angle at which the swimmer travels. To help with this problem, we can make a diagram of the river. The two arrows pointing to the right show that the current is going to the right. The initial velocity of a swimmer is labeled as 2 meters per second, as stated in the problem. The starting point and ending points are very clearly labeled. The vertical dotted line is labeled 120 meters to represent the width of the river, and the horizontal dotted line is labeled 50 meters to represent how far the swimmer swam across the river. Starting with A, find the speed of the current. Speed and distance are directly proportional. So the ratio of the distance traveled downstream to the width of the river is equal to the ratio of the speed of the current to the speed of the swimmer. Knowing that, we can set the distance traveled downstream divided by the width of the river equal to the velocity of the current divided by the speed of the swimmer. To fill in the values, we have 50 meters, which is the distance traveled downstream, divided by 120 meters, which is the width of the river, set equal to x, which is the unknown value for the velocity of the current, divided by the speed of the swimmer, which is 2 meters per second. To solve this, you would multiply 50 times 2 to give you 100, and then divide 100 by 120 to give you 0.83 meters per second, which is x, or the velocity of the current. For B, you have to find the swimmer's final speed. Once we have the speed of the current, we can use the Pythagorean theorem to find the final velocity of the swimmer. The swimmer's final speed is represented by the line directly between the starting and the ending point in the diagram. The Pythagorean theorem consists of the equation a squared plus b squared equals c squared. In this problem, a represents the initial velocity of the swimmer, and b represents the velocity of the current. Adding these two together will give us the swimmer's final speed. To solve this, 2 is the initial velocity of the swimmer, and 0.83 is the velocity of the current. So 2 squared plus 0.83 squared is 4.6889. Then we can square root that number, which gives us 2.2. For C, we have to find the time it takes the swimmer to cross the river. Time is the ratio of displacement to velocity. The displacement and velocity you pick for the ratio need to have the same direction. The two ratios to pick from are the ratio of displacement downstream to the velocity of the current, or the ratio of the width of the river to the initial velocity of the swimmer. The important thing to remember is that no matter which ratio you choose, you get the same answer. 50 divided by 0.83 equals 60, and 120 divided by 2 also equals 60. This means the time it takes the swimmer to cross the river is 60 seconds. Lastly, D asks us to find the angle at which the swimmer travels. To do this, set up a diagram and use the term SOHCAHTOA. Your diagram should look similar to this diagram that was shown in the beginning of the video. We should have a right triangle where the unknown angle is indicated, and our two known side lengths are 120 meters and 50 meters. To use SOHCAHTOA, we first have to label the sides. We know the hypotenuse is the longest side, and then to find out which side is the opposite or the adjacent side, we have to use the angle. Whichever side is to the opposite of the angle is the opposite side, and then whichever side is next to the angle is the adjacent side. Now, to actually use SOHCAHTOA, we have to determine which function we will use, sine, cosine, or tangent. Since our two values that we know are the adjacent and the opposite sides, we will use A and O. The only function that has a and o is tangent. Now to actually solve for the angle, we use the tangent of theta is equal to opposite over adjacent. Theta is the symbol we use when we don't know an angle. Filling in the values, you get the tangent of theta is equal to 50 divided by 120. The tangent of theta is then equal to 0.416. From here, you take the inverse of both sides using the calculator. To do this, you would click second tangent and then plug in the 0.416. This gives you 22.6. Now we know that the angle at which the swimmer travels is 22.6 degrees.